everyone. My name is Jyoti Vasudev, and today I'm excited to share my project on implementing retrieval augmented generation for Ayn Rand's The Fountainhead. This project combines advanced natural language processing with retrieval techniques to explore how we can extract meaningful insights from large, complex texts. So let's start with the basics. What is retrieval augmented generation? RAG is a hybrid approach that combines retrieval mechanisms with the generative capabilities of large language models. Traditional language models are great at generating texts, but can sometimes hallucinate information or lack grounding in specific contexts. By incorporating a retrieval component, RAG ensures that generated responses are based on actual data sources, improving accuracy and reliability. This project, I used RAG to analyze the Fountainhead, focusing on key themes, character analysis, and significant plot points. Now let's discuss the problem statement. When working with large text like novels, it is challenging to extract accurate insights without manually sifting through hundreds of pages. My goal was to automate this process by building a pipeline that retrieves the most relevant text chunks and generates responses to user queries. The dataset for this project was the full text of the Fountainhead in PDF format. I used PyPDF2 specifically to extract and pre-process the text into manageable chunks of around 500 characters each. So this is done right over here. So I load the text here, then split it with recursive character splitter in chunks of 500. And here's a quick overview of the implementation workflow. So this is where I read the PDF with PDF Reader, extract the text right over here, and then divide it up into chunks of 500 for efficient retrieval. I use sentence transformer to encode these chunks into vector embeddings representing their semantic meaning. Use a similarity retrieval mechanism. So when a user asks a question, the system calculates the similarity between the query that is asked and all of the chunks that we just created to find the most relevant chunks. And that happens right over here. So I've defined individual functions for each one of these tasks for better modularity. And so when a new query comes, that query is encoded or embedded into vectors. And then an index search is performed to find k most similar chunks to this question that was just asked. And k I've defined as 5 for the examples that I'm going to use. And then when I have the retrieved chunks and I have created the context with these, I have the new question and so at that point, I use GPT-4 model to make the actual language model call. So this prompt is defined right over here. Query is the question that the user asked. Context is the retrieved chunks which are most relevant to the question asked. So the prompt that we provide to the language model is from within this context, find the answer which will be relevant to this question that was asked. And I'm using GPT-4o to do that. And to quickly test the actual performance of the pipeline that we have built, I have also built a small UI within the Jupyter notebook for just easy visualization. So let's say, what are Rourke's view on integration? Okay, what are ropes around individualism? And we're going to say views. Generate answer. All right. This is the answer. Environments founded at Harvard Group embodies rigorously advocates for individualism, views individualism centered on belief that creative independent mind is of supreme value. Now that from the first few lines, the answer does seem to be very relevant to the question that we are asked. So pipeline is indeed working. The text provided to it was the entire book of Fountainhead, and it was able to answer a specific but still abstract question that we just asked to it. Okay, for the visualizations, I've put in a few visuals for the tool that I've built, the ones that could be used as visuals. So the first one is a word cloud. This shows the most frequently occurring words in the generated responses, highlighting the dominant themes like individualism and integrity and success and all of the other things that could easily be associated with an Iron Man novel. And there is chunk similarity heat map. This heat map visualizes pairwise cosine similarity between text chunks, revealing how semantically related different parts of the text are. And it's rather blue. Everything seems to show low correlation except for the texts which are adjacent to each other, which is perfect because that is just what we want to see. Also, it in case of a fiction novel, it kind of implies and indicates the quality of writing with the diverse range of genres and topics that are covered within a single nonfiction novel. And then I have one more visual here, which is principal component analysis embedding distribution. This scatter plot reduces high dimensional embeddings into a 2D space. Widely distributed points suggest diverse themes and ideas within the text, which is what we are seeing here. So we saw from our testing of the pipeline that the system accurately responded to the question that we asked to it. It was able to effectively identify relevant chunks and generate contextually accurate response. It is possible if we ask it something sufficiently abstract that it is not able to provide an answer that is specific enough because the nature of the question is not specific enough. But there are a few ways in which the performance can potentially be improved if I were to build upon this work so far. And that is if I could add multi-level indexing, that could improve retrieval speed, testing with other large text and increasing the context sizes another way that this could approach could generalize further. The index search is able to effectively identify the chunks, the embeddings using sentence transformers are is the embeddings are effective enough such that the vectors are able to be matched based on user's question. And the chunk size seems to be just fine for our use case in particular. That's my project for this course. Thank you for watching. I hope this presentation gave you insight into RAG and its application, one potential application. If you have questions about this or would like to explore this further, I would love to talk with you and show you greater details on some of the other things that I've done and more about this. Thank you.